Okay, here we go with lesson 4.7. This lesson is about the radical equations and inequalities, except we really aren't going to deal with the inequalities. We're just going to focus on the equations. And you might ask, what is a radical equation? Well, a radical equation involves an equation that has a radical sign in it, like I've shown, square root of x plus 3 equals 8. So our objective for this lesson is basically just solving these. There are a few steps that you might want to keep in mind for steps to solving a radical equation, and they are: number one, isolate the radical. And why don't you guys take a moment and just write these 3 steps down and try to keep them short. Step 2, use inverse operations to eliminate the radical, which means basically we're going to be raising the radical to the appropriate power. So when I have a square root, I'm going to use the power of 2. If I have a cube root, what undoes it is a power of 3, and a fourth root radical I would take to a fourth power, that sort of idea. And the third step that we're going to be doing is checking our solutions to make sure that they are not extraneous, or in other words, solutions that don't work. So we always want to do a check back on that. All right, so problem number 1, take a moment to write this problem down. 7 plus the cube root of 9a squared minus 35 is equal to 5. And over on the right hand side, I have placed the 3 steps that we're going to be working with. 1, isolate the radical. That means get the radical by itself. So I'm going to first take and subtract 7 from each side. That'll leave me a cube root of 9a squared minus 35 equals negative 2. Second step, I want to get rid of my radical. So I am going to take and raise this to a third power, because then the cube and the cube root basically will kind of eliminate each other. 9a to the second minus 35 is equal to negative 2 times negative 2 times negative 2, which makes negative 8. Continue to solve your equation. Add 35 to both sides. We get 9a squared is equal to 27. And then we'll divide by 9. And that will leave us with a squared equals 3. And I will get plus or minus the square root of 3. And then we should probably take our answer and check for the solution. I'll bring that solution back up in, and that will give me 7 plus cube root 9 times square root of 3. I'll use the positive one first. Square it minus 35 equals 5. 7 plus cube root of 3 times 9 is 27. 27 minus 35 is negative 8. Cube root of negative 8 is a negative 2, and I get 7 plus negative 2 equals 5. And that checks out. 5 is equal to 5. So that works. What if we put in a negative coming from this solution of negative square root 3? If I square negative 3, negative square root 3, I still end up with positive 3, and 9 times that's 27, and it'll follow through on the same steps. We would get 5 equals 5 on that. So it looks like we have both solutions, a plus and a minus square root 3 as our solutions. Next, problem number 2. X equals square root 2x minus 5 plus 4. Once again, isolate the radical. Subtract 4 from each side. Gives me x minus 4 is equal to the square root of 2x minus 5. We want to get rid of the radical, which is a square root, so we are going to take and raise to the power of 2. both sides. What you do to one side, we should do to the other. Easy on the right side, we will get 2x minus 5. Over on the left side, this really becomes a foiling. X minus 4 times x minus 4. There is a pattern to these. I will have x squared because I get x times x. I'll get a negative 4x and a negative 4x. You really get 2 times the product of each of those multiplied. So 2 times 4x plus 16. This middle really becomes x squared minus 8x plus 16 equals 2x minus 5. And continue solving. So now we're going to work on getting everything to one side because we are at a quadratic stage. I'm also going to add 5, so I'm kind of doing 2 steps here in one line just to keep it a little shorter. I'll have x squared minus 10x plus 21 equals 0. And now I think I'll use factoring from here because this will factor very nicely. X minus 7, x minus 3, 7 times 3 equaling the 21. And finally, the roots or the solutions would be x equals 7 from our first factor, x equals 3 from our second factor. We should take and plug those in, make sure that the solution checks out. If I run 7 back up in here, I get 2 times 7 is 14. 14 minus 5 is 9. And the square root of 9 is 3. I end up with 3 plus 4 should equal x. And remember, x, we started out with it being 7, so 7 equals 3 plus 4. It works. Next, we should plug in the 3 and see if that solution works. So if I go 3 in here, I'm going to get 2 times 3 minus 5. 3 goes in for x there as well. Add 4. 6 minus 5 is 1. Square root of 1 is 1 added with 4. And this one does not look to be like it's going to work, does it? Because 3 does not equal 5. So I'm going to stick with a root at x equals 7. Excellent. Problem number 3. Isolate the radical again. So first step, let's add 6. Add 6 to each side. I'm going to get the cube root of x plus 3 equals a 1. Raise each side to a power so we can get rid of the radical. I get x plus 3 equals 1. Subtract a 3. X equals negative 2. If I take that and put that in as a solution, I'm going to have the cube root of negative 2 plus 3 minus 6 equals negative 5. Cube root of 1 minus 6 equals negative 5. Cube root of 1 amounts to 1, so I get 1 minus 6. And negative 5 equals negative 5. I like that solution. X equals 2 is our solution. Number 4, isolate the radical, and then you will raise each side to a power of 2. I'm going to skip this one just to save us time. We've done one similar to it, and let's just do this very last one. So the very last problem, what happens if I end up with an equation that has more than one radical to it? Well, the first thing I would do is get your equation so that you have a radical on each side. So I'm going to add this radical over to this other side. So I'm adding the entire radical and the stuff that was underneath it to each side. That's going to leave me with square root of x plus 1 equals square root of 2x minus 12 plus that 1 that was already over there. So we've isolated the radicals, got each one on a side. Now in order to get rid of a square root, it would be best to square it. So square that. Squaring this side looks relatively nice. We get x plus 1. Squaring the other side, though, not such a nice deal. Remember, this would look like square root of x minus 12 plus 1 multiplying by itself. So do the FOILing. Radical times radical. Those radicals will clear away each other, leaving me 2x minus 12. I'll have this one and then one from that, giving me a grand total of 2 times the radical. And then last times last will give us a plus 1. I will simplify what I can. X plus 1 is equal to 2x. 1 plus negative 12 gives me negative 11 plus 2 square root 2x minus 12. Well, now I'm down to an equation with just one radical. So let's go back to what we know how to do, isolate that radical. All right, so I'm going to subtract 2x, get it to the other side. I'm going to add 11 to the other side as well. That's going to give me a negative x, a plus 12, and that's going to equal 2 square root 2x minus 12. Now, you're probably thinking, well, maybe we should divide by 2, but then that's going to make this side, the left side, rather ugly. So I'm going to leave the 2 where it is, and I'm going to come in and square both sides to try and get rid of the radical. Square, square. Squaring this will be negative x plus 12 times negative x plus 12. That will look like x squared, a negative 12x, and another negative 12x, making negative 24x. Last times last brings me in at 144. Squaring the right-hand side, 2 squared is 4, and squaring a square root will make the square root go away. So I'm going to just have the stuff from inside the square root, 2x minus 12. Distribute the 4 through, and that's going to give me 8x minus 48. Left side still remains the same. X squared minus 24x plus 44. Now, let's get everything to one side, and hopefully we can either factor or we can quadratic formula. That would be another option. So we get x squared minus 32x plus 192 equals 0. And believe it or not, this is factorable. X minus minus, we know our signs, and things that multiply to give us 192. I know it's an even number, so I'm just going to start checking with some even numbers. I'm going to divide 192 by 6, and 192 divided by 6 leaves me 32. So my numbers would be 6 times 32, but that looks like it's going to be kind of large. That ends up being 38, so that is not my number. Maybe I'll take 192 and divide it by 8. Try that. 192 divided by 8, and that gives me 24. So what if I popped in 24 as my number? 8 and 24. Oh, well, that's nice because those two make 32, don't they? So I'd have my middle term at negative 32. I would get answers x equals 8 and x equals 24. My two solutions, and I do believe if we checked them out, they would work. So that is all that we had to do on that one. I'm going to page forward. This will be the homework that we get started with tomorrow. And so basically you just had to listen to the video tonight and we're all good. Thank you.